Call expressions are the most important type of expressions in programming. They involve calling some function on some arguments. A call expression looks like this. You can recognize it by the parentheses that have some function before them. Now this whole thing is called a call expression, and it has parts. The operator is the part that comes before the parentheses. It describes what function you're going to call. In this case, the name add gives you the function that adds two things together. The operands, 1 plus 1 and 3, come inside the parentheses, separated by commas. Operators and operands are also expressions, and expressions evaluate to values. So the add name evaluates to the function that adds, and 1 plus 1 evaluates to 2. 3 is really simple. It evaluates to 3. So we're adding together 2 and 3 to get 5. How does that work? Well, there's an evaluation procedure for call expressions that applies to every single call expression that gets evaluated. It goes like this. You evaluate the operator first to figure out what you're calling. Can't call it yet because you don't know what you're calling it on. Then you evaluate the operand expression, so you add 1 and 1 to get 2. You evaluate 3, which is just 3. And now you've evaluated all of these parts, and it's time to apply the function. So now it's time to actually add 2 and 3 together. Apply the function that's the value of the operator to the arguments 2 and 3, which are the values of the operands 1 plus 1 and 3. This terminology, operator and operand, is not quite the same as what's used in the Python documentation, but in this course we'll use operator and operand to describe the parts of the expression and the function and the arguments to describe the values that you're manipulating. If you have a nested call expression like this, you just apply that procedure over and over again. Evaluating the name mul gives you the function that multiplies. Before you can multiply, you have to know what you're multiplying. So you have to evaluate add 4 mul 4 6. Add is evaluated easily. You just look up the function that adds. 4 is 4, but multiplying 4 and 6 again means applying that same procedure that evaluates the operator and the operands. And now we finally reach step 2. We're in the middle of step 1 for the whole expression, in the middle of step 1 for the whole expression here, and for here. And now we've reached step 2, which is to actually multiply 4 and 6 together to get 24. Now we can finish adding, because we know what we're adding. So we'll add 4 and 24 to get 28. We still can't multiply because we don't know the other argument. In order to do that, we have to evaluate the other operand, which means we have to add 3 and 5 together to get 8. Now we can multiply 28 and 8 to get 224. What we're actually doing here is pretty interesting. We're building up a result from a complicated expression without a lot of complicated rules. Instead, we're just applying the same rule over and over again. When we start with a call expression, we evaluate it. And when we reach another call expression, we evaluate it. And the procedure for evaluating the big one is the same as the procedure for evaluating the small one. It's just the small one finishes sooner because it doesn't have any large call expressions within it. This whole thing is called an expression tree, and it's a way of visualizing the process of applying that procedure for evaluating call expressions over and over again in order to build up a final result. And the last thing I'll add is that this idea of having a procedure, like evaluating a call expression, which itself invokes the same procedure, evaluating another call expression, is called recursion. This recursive procedure actually involves running itself in order to get it done. What do I mean by that? I mean, to evaluate this call expression, you have to evaluate a call expression. And to evaluate this call expression, you have to evaluate a call expression. So that self-describing or recursive character allows us to have one simple rule that does a lot of work by applying it many, many times.